Hello everybody, this is Gary LaBombard again. This is video number 13, a continuation of my 1973-05 Eagle refurbishment and modifications. This video is going to have some repeated information from other videos that have already been shown, but to complete my information and update everything to this date, it is necessary to show repeated information. These next photos are my new engine to be used in my bus, and the modifications I made to the engine to satisfy me. You are seeing my process of setting up my engine on a test stand in steps and how I plumbed it all together to have coolant running through the engine while running. Here's a comparison of how my engine looked when I first purchased it and in the bus, and then you're going to start seeing some of the modifications that I did make. You will see my control panel I made up with gauges for temperature and oil pressure, the use of my actual new air throttle shuttle, and the newer, less congested way all my fuel lines are now run, and support the engine versus the other way that they were run from the factory. You can also see my original governor control valve linkages, which left much slop in controlling the speed needed to run the bus. I fashioned my new governor fuel linkages after another bus nut, Paul Lowry, who set up his bus similar to how I am trying to use my air throttle. And I'm glad he published his information, which I'm using as a guide to put me in the correct direction. And I also hope I too am passing on information in all my videos published to help others. My new direct movement governor linkages are tight with no slop or hesitation when operating the governor speed control. I do not have only two photos of my system, but you can clearly see how it operates in the views shown. Look closely at the next photos, as I also included fuel shutoff valves on both the primary and secondary fuel filters. This is for a couple of reasons. I can manually stop the flow of fuel to the engine and stop the engine within a few minutes to stop a runaway and so forth. Also, these valves make it easy to prime my engine using a mounted 1-gallon jug with fuel and a hand pumped into the fuel filters to fill them if prime is ever lost for any reason. And also to make sure that there is no error in the air lines after removing the fuel filters to change the new ones. After the testing of my engine was successful, and tear down of extra parts removed that was used just for testing purposes, I decided to also insulate my entire engine exhaust from the manifold to the exit end of the muffler to cut down on noise from the engine, heat from the engine, exhaust rising up through the engine compartment to the cabin bedroom. This was just an afterthought of my part, hopefully to make my engine run cooler. The engine compartment was refurbished first and modified in areas needing this, and then the reassembly of the engine was done. I put my engine back into my bus after all modifications I wish to do were done. Just some of my modifications included all my air tanks were replaced, relocated, and enclosed to protect them from road debris, such as in the first photo shown. This involved installing all new air valves and air lines throughout the bus. Notice the welding done on the end of one of my air tanks in particular. It was leaking like a sieve, and as was the entire air system. The original air tanks were mounted directly over the drive wheels as shown, being contaminated and rusted out over time. Now here comes where the original tanks were right over the wheel wells. Look at that. I mean, it was unbelievable when I took those tanks down, just the condition that they were in. Now you will see the new air tanks being fitted into their new storage areas. They're painted and fitted with air valves and lines in the future here. Looking close, you can also see the enclosure of the entire wheel well framing, and finally the ending of the closing of one of the air tanks with an access door, making it possible to enter a protected area if needed in the future. Coming up now is a photo of the new air tank area enclosure, all buttoned up and ready to go. Doesn't that look pretty? Look at the two main drive brake cans off my bus. These are DD3 brake canisters, and they're horrible and all dented up and everything else. And knowing that everything in my bus was also abused and needing replacing, I decided to change my bus over from DD3 brake canisters to a more simplified system of spring brakes. And I'm so happy I chose to do this. My new drive wheel spring brake cans had to be retrofitted and the support brackets modified for the new spring brake system. After fitting the brake canisters, plungers to the correct length for activation of the system, I also now have a way to cage my rear brakes if needed so the bus can be towed or moved and not locked down. The new spring brake cans are mounted and connected after all modifications needed are done on the drive wheel. All wheels received new brake cans in place of the originals when I purchased it. I had to make conventions and mountings to be fabricated for the entire bus at times without having access to actual design tools that were used to assemble the bus in the first place. The first one is just a simple bracket that was designed, fabricated, and mounted in areas needed to mount air valves, air controls, and so forth. It's a real simple design, as you can see. Everything I do, I try to keep it as simple as I can. And in a moment, you're going to see it where it's actually mounted and it's used, such as coming up right now. This is in the front of the bus. There's no more valves or nothing in the back of the bus or underneath the tunnel or anything like that you can't have access to. Everything's up in the front or in the back. The bus starting battery compartment came out good, with all the new heavy-duty cable installed to properly disperse the current used to start the 8V71 engine. Connection to the power cutoff switch is not done in these photos, as safety is done to protect me and the bus while working in all areas near the battery compartment. The driver protection area in the front of the bus that failed and nearly caused the driver to die, but didn't cause the driver to lose both his legs. If you're looking at these photos now, this was his bus as I seen it. The front of the bus, the front end driver protection area is revisited, as this is the most important after seeing what is actually there for protecting of the driver. This is the similar design of all Eagles I know of. You can see the steps I took to redesign, fabricate, and install my new front end framing. I may have over-designed and overbuilt the front end of my bus, but that's just the way I do things. So now I don't think I have to worry about anything if a head-on crash, which I hope I never have to experience. But I think I have more protection than what the fellow did that had his bus damaged all in the front when he ran into the back of a tractor trailer. You can see the pictures, the steps that I took to build a cage in the front. This took several weeks and a lot of welding, a lot of cutting, and just a lot of time. Here comes the finished product. That just painted without the skins on it, of course. It's just painted, primered, and then here it is again waiting for the skins to be put on. I even redesigned the layout of my drive dash gauges and added individual air tank gauges for each of my air tanks to observe which one may be leaking to help troubleshooting if I suspected there was an air leak. I also have installed a tachometer, which I did not have also, and I have to get a new idiot light panel for the top of the dash now. And here's the finished product. I designed my utility bay for shore power control panel, circuit breaker box, and new shore water system manifold for the bus and my utility bay with built-in water filter and permanent 40-pound pressure control gauge to control water pressure at campgrounds. Nothing's been tested at this time yet. Just installed. And there's the water system all plumbed up. A handy tool that I invented to cut down on the messy job of packing wheel bearings with new grease was using a grease gun and a very small nozzle used to install grease between each bearing individually from both sides of the bearing. You can see how I have fabricated it together, and it worked really well. You didn't have to get your hands off full of grease or anything like that there. And you're going to see how I was able to install grease on both sides of the bearing. A hand tool I invented was to remove airlines connected to push-on type connectors used in new airline system. All sizes of airlines can be removed by bending older open end wrenches, such as I did, and just hold the wrench against the locking ring of the connector and pull your airline out. Another tool designed and fabricated I call is the brake separator tool. This holds the brakes open so that you can install new brake rollers, or you can remove the cam easier without taking everything all apart and everything like that there. And it's very simple and very effective. And making one of these tools is very easy to do. It just takes a little thought. And if you really need one or something like that, I've got several that I made. I don't mind selling them to you if you're interested in any way. But you can look at my design, and you can just clearly, if you have any common sense, you can figure out how to make them if you have to. It's a real handy tool, and you're going to thank me one day. And it'll save your fingers and everything else too at the same time. Another tool made was very simple, and you can also make it by just taking a look at mine, is the crankshaft turning tool that is bolted directly to the engine crank with two bolts, making it possible to rotate the crank using a 3/4 inch drive ratchet to line up gears when you're changing your timing of the bus and so forth, or setting the injectors and running the rack. Real handy tool. A 1-inch nut has to be welded in the middle of your bracket so that you can use the socket and your ratchet in order to rotate the camshaft. I came up and fabricated a fixture that was best necessary to remove my bogie arm, and I call this the separator tool, which made it possible to remove the bogie arm assembly. This was made safe and possible using a 20-ton hydraulic jack. It took a little time to fabricate everything all together, and you got to have some pretty heavy-duty metal to do it too. But it made separating the arm from the twist elastic tube very easy. Remember, everything that I make so that only one person has to use it, but 2 people is great, but 1 person is all I have available to me. To press out my old wheel studs, I copied a device I saw on the internet, and I made it for myself, and it works really great, but it's quite heavy, and the jack that I had was a real long one. I advise anybody that wants to do this, look at the pictures real close. You can see that if I use a shorter jack, it's all I need. You only have to go about 3 inches, if that, to take a bolt out, and half of that to put the bolt back in. But the jack makes it easier so that you don't have to take a sledgehammer and pound them out or anything like that, like you did in the old days. Here's a good clear view of how it's made to press them in. Right there, I'm getting ready to press it in, the new bolt in. And as you press it in, it goes into the bracket on the right-hand side. But modifying this to make it smaller, it'd be a lot easier to do than with the only jack that I had available to me. You gotta spend some money, I guess. This is the end of video 13. I appreciate you all taking and viewing the time to view my video, and I hope I gave you good information for all the things that I included on this video. Again, thank you for viewing.